Dr. Maithili Paranjape. I am one of the science faculties at Shrishti School of Learning. The subjects that I handle is biology and chemistry. I teach from grade 7 to grade 10 of all students from all boards. So today the topic that I am going to talk to you about is the topic of how to determine the valency of an element. Now, valency of an element is considered to be one of the fundamental concepts in chemistry. Now, what I have realized is students, they do not understand how to determine the valency. They tend to by heart it. But if they go wrong in the valency of an element, what they go wrong is in determining the molecular formula of a compound. Once they write the molecular formula of a compound in an incorrect way, they go wrong in writing a chemical equation. When the chemical equation goes wrong, they go wrong in balancing a chemical equation. So the entire process goes wrong only because they have gone wrong in determining the valency of an element. So today let's understand how do we determine the valency of an element. Valency of an element is defined as the combining capacity of an element. For example, let's take two elements A and B. Now when A and B, they combine with each other, they form a chemical bond between them and they form a compound. Now all elements do not have a stable octet configuration, which means that they do not have 8 electrons in their valence shell, and therefore they either donate an electron or they accept an electron or they share an electron in order to get a stable octet configuration when they form a chemical compound. To determine the valency of an element, there are two things that you need to know. The first thing that you need to know is there are how many electrons in a particular element. So the number of electrons which are present in a particular element, that is the first thing that you need to know. The second thing that you need to know is that you should be able to write the electronic configuration of an element. So what does electronic configuration mean? Electronic configuration talks about the distribution of electrons in different shells. For example, it could be in the K shell or the L shell, M shell or the N shell. How the electrons are distributed in the 4 shells. Now, how do you get to know the number of electrons? The number of electrons are also equal to the atomic number of an element which is represented by Z. Because you know that any atom is neutral in its charge. So electrons being negatively charged are equal to the number of protons, and number of protons are represented by your atomic number, which is your Z. Therefore, if you know the atomic number of an element, you will come to know how many electrons are present in that element. After you know the number of electrons present in a particular element, you should be able to distribute the electrons in the orbits depending upon the number of electrons. Now when you distribute these electrons, one very important rule that you need to remember is the rule of octet, which states that the maximum number of electrons which can be present in the valence shell of an element are just 8 electrons. So maximum number of electrons present in the valence shell of any element is 8. Now let's understand this by taking a couple of examples. Suppose an element has 1 electron in its valence shell, or if it has 2, if it has 3, if it has 4, if it has 5, it has 6, it has 7, or it has 8 electrons in valence shell. It cannot go beyond 8 electrons because according to the law of octet, the maximum number of electrons which can be present in the valence shell, which is the outermost shell, cannot go beyond 8 electrons. So these are the only possibilities with the number of valence electron of a particular element. Now suppose an element has one electron in its valence shell. It can easily donate this one electron and therefore its valency is 1. So this becomes the combining capacity of that element. Combining capacity is what it is able to donate one electron to another element so that it gets its stable octet configuration and therefore its valency is 1. An element with 2 electrons in its valence shell can easily donate 2 electrons and therefore its combining capacity is 2. An element with 3 electrons in its valence shell can donate 3 electrons and therefore its valency is 3. An element with 4 electrons in its valence shell does not donate nor does it accept electron, but it shares 4 electrons with another element and therefore its valency is 4. An element with 5 electrons in its valence shell cannot donate 5 electrons. But what it does is that in order to get its 8 electrons in the outermost shell, it accepts 3 more electrons, and since it is accepting 3 electrons, its combining capacity is of 3 electrons and therefore its valency is 3. An element with 6 electrons in its valence shell needs 2 more electrons in order to complete the octet configuration and therefore its valency is 2. An element with 7 electrons in its valence shell needs to accept 1 electron from another element and therefore its combining capacity is 1 electron and therefore its valency is 1. An element with 8 electrons in its valence shell is chemically inert. It doesn't have to accept nor does it have to donate electrons and therefore its valency is 0. Its combining capacity is 0 because it does not combine with any other element, because it already has its 8 electrons in its outermost orbit and therefore it is chemically stable in nature. So depending upon the number of valence electrons that are present in a particular element, you can determine the valency of element. Now when I'll just go through it once. So element with 1, 2 or 3 electrons, they tend to donate 1, 2 or 3 electrons and therefore its respective valency is 1, 2 or 3. Elements with 4 electrons in its valence shell has a valency of 4 because it shares 4 electrons with another element. Elements with 5, 6 or 7 electrons in its valence shell, it tends to accept either 3, 2 or 1 electron from another element respectively and therefore its valency is 3, 2 or 1. Because 5 plus 3 is 8 or 6 plus 2 is 8 or 7 plus 1 is 8. Basically the aim of the entire process is that they get a stable octet configuration in its valence shell. Now let's take a couple of examples of elements and determine their valency. Let's say we take an example of oxygen. Oxygen is an element which is represented by the symbol O, and its atomic number Z is equal to 8. When you write the electronic configuration of oxygen, 8 electrons will be distributed in 2 shells, the K shell having 2 electrons and the L shell having 6 electrons. So there are 6 electrons right now in its valence shell. So what does it need? It needs 2 more electrons from another element so that it gets its stable configuration. So what does oxygen do? The combining capacity of oxygen is of 2 electrons and therefore the valency of oxygen is 2. After it accepts 2 electrons, it gets converted into an anion with O2 minus charge and the valency of it is 2. Let's take another example. Suppose you take an example of sodium with the symbol of which is Na and its atomic number is 11. When you write the electronic configuration of sodium, the configuration is 2, 8, 1, which means the K shell has 2 electrons, L shell has 8 electrons and M shell has 1 electron. So sodium, if it donates this 1 electron, it will get a stable configuration with 8 electrons in its outermost shell, and therefore the combining capacity of sodium is 1 electron after it donates 1 electron, and therefore its valency is 1. After donating this 1 electron, sodium gets converted into Na plus, which is an cation, and the valency of sodium becomes 1. So this is how you determine the valency of an electron.